All right, folks, so this is week 13, Excel Lab 5, and notice that the keyword here is relationships in real estate. So we're looking at any type of linear regression, whether multivariable or just simple linear regression. What they're asking you to do is basically take this Excel sheet and you are going to take a sample of 10 from it using random int, or we could use random integer. I'll show you how to do that in a minute. And you're going to select 10 random data points. And using those data points, we are then going to run a linear regression. We're going to create a scatter plot. We are also going to talk about the hypothesis, and we are going to look at the results using a 5% significance level. We are also going to look at the regression equation and predict what the property taxes for a home that is 1,500 square feet would be. So once you run the data, obviously the next step will be to discuss it. So you need background information on this. I'll help you with some of it, but the rest of it is up to you. Okay, so let's begin. So first thing we're going to do is we're going to open up this Excel sheet that they gave you, and this should contain tons of data on our properties. I'm going to open that file. Oh, that went well. I'm not quite sure what protected view means, but let's try this again. Let's see if we have better luck this time. There we go. And so we're going to go to the sheet. Notice in the bottom of the sheet, there are two tabs. One of them says raw data and the other one says sample data. So what we're going to do is we're going to click on this. Okay, and this one contains our raw data. So if you notice, as I scroll down, there's 30 samples, which is a nice size. Or we're going to take 10 from these 30. So what you're going to do is you're going to do equals rand between, double click on that, and we're going to do 1,10, and you're going to hit enter. Now once you do that, go ahead and drag and drop. Okay, and so as I look at the numbers, I'm thinking I'm just going to grab, starting from the top, numbers 1, 2, let's see, do I have a 3? I have a 3, I have a 4. If I don't have a 4, I'm going to take the first 7. Do I have a 5? I do. 6, 7, an 8, a 9, and a 10. If I don't have it, I'm just going to select from the order of what I have here. So I'm going to grab the first one, which is 219. So think of it this way. This is my 1. This is my 2. So maybe take a picture of it because the values are going to move. As I take a picture, I'm looking at 1, 2. This might be my 3. This is going to be my 3, my 4. Actually, these are right next to each other. So 3, 4, and 5. So I'm going to select this one as my third. Well, actually, I'm going to select this one as my third. I don't like that it keeps moving on you, though. That's going to be a problem for you. All right, so maybe we'll use another method. Or, like I said, take a picture, and then you can go from there. So if I took a picture, I'm just going to do a snipping tool. Let's do that. You can use your phone. I just don't have my phone with me. But if you take your phone and you take a picture, it's the equivalent of taking a freeze frame shot, right? So that's my picture, my equivalent of a picture, and I'm going to use that to select my sample. All right, so maybe do that. That might be easier for you. You can then go to sample data. If I go to sample data, I still have my snip with me here. And so using that snip, let let me move this aside this way. What I'm going to do is I'm going to start with my first number 1, which is the 43988 property, which is size 5665. Okay, so that's my 1. My 2 is way up top. So if you notice, I'm kind of trying to stay in the order in which those numbers appear. All right, that's my 2. It looks like my first 3 is 16706. All right, and then I'm going to select 1964. All right, do I have a 4? Let's see, let's go through this top. Oh yes, I do have a 4 here. I don't see a 4 anywhere else, so I'm going to go with this 4, 35478. So 35478, and this is 2698. All right, now I need a 5. The first 5 that I have is, I believe, right here. So that's 16073, 16073, and this is 1380. Okay, now I need a 6. My first 6 is right here, the 31043. So 31043, and this one is 2876. All right, now I need my first 7, which is way up there. It's 17339, and this is 2479. Okay. Let's see, do I have my first 8 right here? 18225. It's 2092. I would assume that's square feet. And then my number 9, ninth sample would be, my first one would be right here. If you notice, that's a 9. So I'm going to use 38968 and 4000. And lastly, do I have a 10? I do up here. And this is 15693 and 1000. So now I have my sample. I use this as my guide for my random sample. And now we're in luck. All right. So the idea is that this is property tax. This is size of the home. We'll use this as an X and a Y. And in this case, we're going to run a linear regression. So basically, you're going to go to data. You're going to go to data analysis. You're going to go to linear regression or just regression. Let's see. We have this right here, regression. Hit OK. And it's asking you for X and Y values. So I would assume that X is my input, because the size of the house is going to determine the price of the house or guide the price of the house. I'm not using labels. I do want a 95% confidence level. And my output, I'm going to place here. I do want residuals. I do want a line of fit. This is not necessary, but I'm going to go ahead and click it anyway. This will determine whether or not the data is consistent. If it suffers from collinearity, that may be an issue. So, okay, so we're just going to toss this in that cell and hit OK. There's our linear regression. Okay, and this is your intercept. That's your coefficient for your X. You do have a strong correlation. It looks like your R squared is 79, so 79%. And we would argue that 79% of the variability in the model is caused by, 79% of the variability present in predicted Y can be explained by variability present in the independent variable. x, or we sometimes just say in the model. We can look at our p-values. You notice that p-value is 0.00529, so that's good. This is questionable because our p-value is 0.12, and typically we would not consider this, but I'm just going to go with the flow here. And our observations, your significance for your ANOVA is good. It's 0.000529. That's good. Okay. Now the other thing that we need to do before we continue with this is we're going to insert a graph. We're going to insert a scatter plot. And this scatter plot will contain all our values. So let me delete that for a second. So we're going to go over here, and this time I'm going to grab the actual titles. We're going to go to insert scatter plot. And now here you notice that there is no LSRL, but we do want one. So we're going to go to trend line because I do want the trend line. You could add, in this case, axis titles. So the axis titles will tell you, for example, this is the size of the property and the price of the property. I would rather reverse these because this should be your X variable. So let me delete that. Let's do this again. And let me tell you what I'm going to do. I'm going to put property taxes. Control copy. I'm going to throw this into the Y. I'm going to take the size, control copy, and I'm going to place it over here. Control paste. And I'm going to run that linear regression. All right, control copy. We're going to go to insert, again, scatter plot. Go to the scatter plot. There you go. And it looks a little bit more aligned. Again, I need a trend line. I don't necessarily need a legend. You could see that it does help you. I'm just hovering over it. You see how it says property taxes is the little dot? And so those are the points. Those are your X values, because technically X, the size of the property, is determining your Y value, which is the dependent variable. You want data labels if you wish to have that. It gets a little cumbersome. Axis titles for sure, because as I said, it makes a huge difference in your approach to the question. So I want size here, property size, and we want to backtrack these fonts. Okay, and this is going to be your, my apologies, this is property taxes. Okay, so this is property taxes paid. All right, and whoa, what did I just do? We just want the name. We don't want everything else. I copied over just because I hit an extra button. Let me just back that up real quick. And then the other side, the other piece, or the other title will be the size of the property. Okay, so I have property taxes already there. I actually hit it twice. Oh, one more edit here. Get rid of that size. That was an accident. Okay, over here I'm going to put size. All right, there we are. All right, and so there's our graph, which is very helpful. Now, how do you interpret all of this information that you have here? Well, basically, at this point, what you have is the predicted Y is going to be equal to this. Let's go with the X values first. So let's go with 7.18. I'm just going to round it to 7.18, but basically I'm using that number. I want equal to, not net, minus. It's a positive, so the X is right here, and then this is plus the Y-intercept, which is 6436.88. Let's go with 0.88 and leave it at that. So it's telling me in this case, because the p-value for the y is questionable, and I say that because it's greater than our 0.05, I would consider running this again with a different set of data, because we always want these p-values to be less than 0.05, or depending on our confidence. You see here where you have lower and upper? These are your confidence intervals, by the way. That's a 95% confidence interval. And so that's important as well. The ANOVA regression is good because this is 0.005, 0.000529. It is definitely p is less than alpha, so we would reject the null that there is no difference between them. So there is something going on here. So it tells us that the size of the property is definitely impacts a property tax that is a little higher. So notice this property tax up here, which is very high. That is a 5,665 square foot home. So yeah, I would expect that to be higher. And look at the lowest point here. If you look at the lowest point, you can tell as well that a small property seems to have a smaller property tax attached to it. So what I want to talk to you about here is the normal probability plot, which a lot of people don't talk about at this stage, but I'm going to. The reasoning here is if we see some sort of patterned anomaly, we would consider this to be irrelevant as far as the data goes, which is why I'm looking here and there seems to be a little bit of a trend, but I can ignore it. I think this is probably the better, it's not a bad sample. All right, the other thing you would consider are the residuals. If you look at the residuals, that's a difference from the actual mean or value that we would assess. So if you look at this little plot here, this goes along with this particular output. So let me squeeze that down so we can look at it. All right, so if you look at these residuals, you have, these are variations from the actual average, which in our case is the 64, 36.88 plus the 7.18. So that's when we look at the residual plot, or not the residual plot, the property line. This is the actual line right here. This dotted line that you see here. That is in essence this line. And so what I'm looking at when I look at a residual plot is a difference between them, right? That's why we have we call it the least squares regression line. In this case, the next thing you would maybe want to do is look at this in terms of the descriptive statistics, which you can run. So I could do descriptive statistics for size as one example. So again, you would go to data, you would go to data analysis, and then what you would do from data analysis, we simply want descriptive statistics, hit OK. And it's only going to do one variable at a time, so I'll do size like I said. I'm not selecting labels. I do want the summary statistics. I would like the confidence, why not? And then here our output. If you want to put the output somewhere up here, I could put it in that. And there you go. Boom. There's your mean, which is 2,660. There's your median with a standard error, a standard deviation, a variance. It even gives you the kurtosis, the range, the minimum, the maximum, and the count. There's your confidence level. Remember, confidence level is simply going to be the 2660 plus or minus that number. Okay. If I do the same thing for property, I put this up here, so let me erase this. So this is your descriptive stats, and you can talk about this. There's nothing wrong with just doing a quick overview of the numbers. And this is descriptive statistics specifically for the size of the property. I would like to do this again for property taxes. So let's skip a column, and I'm going to put property taxes right here. And I'm going to do the same thing. I'm going to run a descriptive statistics analysis on that. So I'll go data analysis. Again, descriptive stats, nothing changed there, but this time I'm going to select property taxes. And I'm going to hit everything else is fine. Notice that nothing changed, just hit OK. And let me cancel that. I'm going to put this in Z. So I want to throw this in here. So hit OK, and there you go. There's your data, your information for all of the property taxes. Again, the same thing with the confidence interval. You would add and subtract your confidence in the mean, so mean plus or minus the confidence interval, and you would have the information you need. Again, you're just discussing it. That's all you're going to do. Now, what's interesting is one of your questions tells us, in this case, what happens when x, that x right here, so let me open this up a little bit, when this x is 1500. So basically you're going to say equals 7.18 times the 1500 plus the 6436. Now remember, at this point we rounded, so it might be an estimate. So all right, and so we would estimate the property taxes, which is a predicted y, to be about $17,006.88. All you're doing in this discussion is basically addressing some of the basics. So let me just go back real quick to our question. And okay, so the correlation coefficient, we're going to talk about that in a minute. So let's go to the correlation coefficient. The correlation coefficient shows up, go back down for a little bit, shows right here. So you'll notice that you have R square, you have an adjusted R squared, but up here you have multiple R. So that's your correlation. Now, if you ever want to verify that, you're going to go equals correl with 2 R's and double click on that. It's asking you for array 1 and array 2, and it doesn't matter how you arrange these. So you could do size, comma, property taxes, or property taxes, comma, size. You're going to get the same answer. All right, and do you notice that this answer matches that answer? If I were to take that number and square it, that's your coefficient of determination, which is the 0.794965. It is interpreted as a percentage. So in this case, if I rounded it to 3 decimal places, I would say 79.5% of the variability present in predicted y can be explained by variability present in the model. That's one end type conversation you can have, or discussion. Or you could say variability present in at the end, just changing the end, variability present in the independent variable, which is size. When you interpret the correlation coefficient, which is the 0.89, you would leave it as a decimal. You would say 0.89.2, rounding it to 3 decimals. So 0.892, given correlation of 0.892, there is a positive and strong association between size and property tax. So again, remember, this is a video. You can rewind it as you need. Your numbers, by the way, are not going to be the same as mine. Keep that in mind. So what are the results of the hypothesis test in the context of this particular run? And so we look at the ANOVA, we look at the output of the ANOVA. We would say that because the ANOVA has a significance level of 0.000529, that P less than alpha, we reject the null hypothesis, indicating that there is a significant difference between um, the variables in terms of property tax and property size. So there definitely is an association between the two variables, right? All right. Then I showed you how to do the regression, so that's it. We have the equation, and we already predicted the tax using the square footage given. And so the next step in your case, after you listen to this and watch some of this, is to actually write it up as a report. It shouldn't take you more than 1 or 2 pages, 3 if you're really, really getting into it. And that's all you need. So you should be great. Best of luck with this assignment. Most people are doing very well.